Well, hi, good morning. Thanks so much for joining me in my shop here for what I imagine is going to be some difficult, I don't even want to call it troubleshooting yet. So I've changed out all the unreliable molded type capacitors and operated the radio and got a pretty dissatisfying result out of that. I think where I'll start today is feeding some signal generator signals into the radio itself and hearing what comes out of the speaker. So I could do this with some audio signals and then eventually work up to radio signals and just have a listen to hear what the radio sounds like under those conditions. So I think the first thing I'll do is I'll get it set up to receive an AM broadcast signal through its antenna, maybe from that signal generator over there. And maybe with a heavier signal we might learn a little more about the radio. Okay, so I've got my signal generator feeding a signal at 1000 kilohertz right into a loop stuck right on the antenna. That ought to provide more than enough coupling. I want this to be on the AM. That's phono AM, 2 short waves and FM. Got it. Okay, there we go. If you heard something there, that was my stomach. There it comes. Magic eye shows a little bit there. There's the motorboating. Okay, so we'll tune in around 1 million here if we can. So 1 million's right here. And the pointer is right here. Get a little more signal here. See, the magic eye is suggesting it's just, the eye itself is thumping. The eye is if you can see that. You can kind of see it. The actual brightness is going up and down, not just the size, but so often when I'm doing this, I make lots of observations and don't say too much about them because I don't know what to make of them. I just making these observations, and maybe later that observation will make more sense to me. Well, now let's see what we can do with a motorboating sound. Change the volume. Well, either the volume control has some damage spots on it, and when it reaches those damage spots, the resistance of the control is going way up. The resistance out the slider part is going way up. an extra high resistance, cutting back the volume so you don't hear so much, and encouraging this feedback. So, is that dirt? Did I not get it clean? Is that what that is? Or is it actually a defective surface? That's a good question. My best move is to make another shot at trying to clean it. I'll try and blast it with a more powerful cleaner here. Part of the reason is that this really puts a blast of gas out. This, oh my god, I'm going to show you what I'm going to use. You're going to freak out. Throttle body cleaner. Yeah, I'm not recommending this. This is what I have. Okay, I'm not recommending anybody do this. This is highly flammable stuff too. So, yeah, not even recommending I do it, but I'm going to do it. You have to get at that volume control again. Just swing the radio around this way. If the volume control is actually defective, then I'm not going to succeed here. Okay. That's a question of when I conclude the volume control shot. And then, do I have another one I can put in there? Whew. Wow, like that one? Like that one? I would doubt it. Wow. Another thing that can be done is you can spray, you can drill a hole in the can and spray through the hole. Looks like I did that on another. It looked like I had done that on another radio I was working on, but I don't ever remember doing it. I'm just going to take this off here before I rip the antenna off the radio. It's really kind of a risky thing I did here. Probably shouldn't do that again. Too many light wires in here. And break them off. Okay, let's have the throttle body cleaner. So in my mind, it's just a very, very volatile solvent of some sort. Throttle body cleaner. I don't think it's anything spectacular. The thing is, it's going to really put out a blast. And that blast can find its way through the little holes here and get right into the control. And then if there is a little bit of WD-40 in there already, right in there. I don't know. Squeaky now. Squeaky clean. Didn't seem like much. Let's turn it on. Phew. Seems to be getting a little bit better. Now it seems the same. So we try another shot. out in the I don't really want to. Oh, maybe I can flip it this way. Maybe that'll get me there. There we are. Okay. Can't see enough. I don't know. Gotta try these things though. Okay, plugged in. Okay, power on again. Squeaky. I'm not so sure that's dirt. I think at this point that motorboating stops, and what that does is while the motorboating is going on, we're probably getting a high AVC voltage. It's quieting the radio. As soon as the motorboating disappears, the radio comes to life. Just at the tail end of the motorboating disappearing, a different oscillation takes over for a moment, very high frequency, very shrill, just for a moment. Now we're past that point. I think we're listening to the radio now. I turn it up. No, you know what? Even when we were, it's always motorboating. Still motorboating. Oh, okay. And if we switch to FM, what happens to the motorboating? If we switch to any other band, let's go to a shortwave band here. Didn't seem to change it at all. Another band, shortwave, same thing. Okay, FM band, still going. So this tells me, and I think it's a pretty safe conclusion at the start of this actually, this problem is in the audio section of the radio. Didn't seem to matter what you're heading towards it. What if I put it on phono? I have to lift the radio up here. So there's phono. No radio. All the same stuff. So we know the problem is in the audio circuits. At least that's one thing we figured out so far. The rest of the radio appears to be working at this point. Can't be absolutely sure, but all indications are it's actually working. Solve this motorboating thing, and then the radio may be good to go right at that point. So, motorboating. Yeah. For sure, the next thing is to study the schematic and try to theorize where this might come from. The thing is, I don't understand motorboating well enough to sit around and just think my way through this, for sure. And I'm sure there's different versions of motorboating go on in a radio. Yeah, I gotta stop for a minute and try to get more in my head. I think I kind of stumbled on something interesting. Don't really know what it's going to amount to, but let's take a look. Noticed this earlier and didn't do anything about it. Took a closer look and thought, oh, what's going on there? Is that big bare wire here? Looks a little hard to see. It's copper all the way back to where the insulation is. It's laying on top of another contact back here, in contact by accident. Comes here, it's soldered to a terminal here, and then it's soldered to the chassis here. Let's take a look at this with a closer camera too, because is it not what I think it is? Oh, it's not what I think it is. That's not bare copper there. Okay. What I was doing was I was taking an ohm meter reading on this nice shiny copper up here. But that's insulation. That's copper colored insulation there. And of course I was getting no conductivity. It also means there's no chance of a short right in here where I was worried that there was a short. Can't be one. The amazing thing was I was getting no conductivity from here onto here, which was freaking me out. But this isn't copper. That's all that's happened. Nothing to see here. There's nothing to see here. Just keep moving. Move along. Once in a long while, I get my camera settings mixed up, and the cameras are off when I think they're on, and they're on when I think they're off, and that's what just happened. So unfortunately, I made a little discovery here, which is quite interesting. I'm just going to repeat it. But it's always much more fun when it's live or first time through. So take a close look at this wire here. This wire. You can see it's a shielded wire. It's coming right in near. This is the cathode resistor for the output tube and bypass capacitor. It's right in the business zone of the output of the. Right, if we follow this back, and I'm just going to quickly stick a tube in here so you can kind of see the situation. I said quickly stick the tube in. There we go. Okay, so that's the output tube, and that's a hot tube, and this wire is running right behind it. And take a look. Can you see that something funny is going on? Some green there. Okay, you don't like to see green on wires. That's not good. Okay, I pull the tube out to get a better look. Now I've already picked this cable apart, and I accidentally didn't catch it on video as I picked it apart. But at first it looked like it might be continuous, but after poking at it a little bit, turns out the shield is open here, and some of this copper is not actually copper anymore. It's copper. What I assume copper sulfate, because of the sulfur in the rubber covering here. And you heat this guy up, and at a certain temperature these materials begin to break down and they volatilize components. Components come off as gas. One of them would be sulfur, some sulfur gas, literally, I guess, sulfurous gas. Attack the copper. Copper wants to not be copper. It'd rather be copper sulfate or copper chloride or almost copper anything. Given the chance, away it goes. I basically have a rock here now instead of a piece of metal. So where's this cable going? So I followed it around, goes down that slot, heads for the volume control, and I was wiggling it here to try to spot it. See, it's coming through that hole there. Sorry to... Excuse me. Boy, I've got to get new lights. The noise is terrible. Trust me, it comes through a hole and attaches to a terminal here, with the shield going to a ground terminal and the conductor going to another terminal. So, you know, could something like that cause motorboating? Well, I don't know. It's right in the audio circuits. Probably both ends of the shield are grounded to the chassis. The fact that it's open in the middle, maybe it's of no real consequence. We don't really know what's happening to the conductor inside that wire either. So I got to replace this shielded wire for sure. And that's what I'm going to do next. And this is where I discovered the video wasn't working, but it worked this time. A little bit of strangeness going on with this wire. Let me take the close-up camera here. Examine the strangeness. What's the strangeness? The strangeness is up here, if I can spot it now. And it's a little dark. The wire is black up here. I'm looking right at it. Black. That's a black wire disappearing past the breakpoint. Black. But that same wire, when it appears down here, is blue. Huh? Yeah, so I'm grabbing it. That has to be it. I practically see my finger on it, I think. How come it's blue here and black up there? Well, there's two wires and they're just so... That has to be the wire. It's not the right color. Okay, let's take a look at the top again. Let me just flip the radio over here. Take another look at it from up here. So, you know, I swear that is black. So the wire up, the entire wire has gone black up here. Ooh, there's a blue wire. There's blue wires in this area. Has it turned blue down there? What's going on? I'm worried I'm going to cut the wrong wire and just get myself into a jackpot here. Does that look blue? Yeah, it might be blue. It might be black. It's the little things. It looks blue down there. The wire changes color from black to blue. Right in the kink. Well, that appears to be what's happening. It appears black up here, blue down there. Let me just see if I can get a little more light onto it here. Yeah, look at that. It is blue. Is that an additional... What is that? Nothing. It's nothing. It's just a bend spot. You can see the blueness kind of fading out as it gets up on top here. It's easy to understand why the heat might make the blue go away, but why way out here? Okay, well, I'm just going to make the whole wire go away. The blue must be the right wire. So I'm gonna replace it from the hard end and finish it off up here on the easy end. And I can cut the wire appropriately as I work my way through it. Yeah, I gotta get new lights in my shop. That creaking noise, I'm accustomed to it. Must drive you nuts listening to it. So I'm gonna snip the wire over here. So this doesn't go to ground on this end. Wait a minute, there's a black wire going back. What's going on there? Oh gosh, what's happening? Put this here. Oh, okay, let's take a look again. Some more funny business here. So the wire comes out, and let me get a grip on it here. Just see it up there. Comes up and around. Shield comes off. This is what I'm interested in. Goes to that floating connection on the end of the resistor, and there's a black wire going down and doing something here. And is that a shield coming off? Another shielded wire? What? Doesn't look like it. If I can see the other side of, oh yeah, I can see the other side of the hole easy. So that's the black wire. It looks like it's broken on the... No, it's not broken. That's not the black one. The black one, what is going on there? Got some tape right around it. It does look like that's a shield. Where's this blue wire go? Oh boy. It's disappearing. It's that one that's moving. Where's it going? Where did it go? It's on the back of this panel here. Oh, there we are. It's going a mile. That's definitely it. Well, what's going on here? We have that looks like a shielded wire who comes around here, this blue wire. The shield is peeled off of it, and it's not go directly to ground, but instead goes to this point with a resistor. How big a resistor is that? Brown, green, brown. So that's like 150. Looks like a 150. And then it's going into the switch here. Everything soldered good there? Yeah. Doesn't look like it, but it is. So the black wire then travels to here, where it's under this tape. Now, why would it go under the tape? Why do they got tape there? Is there tape there to protect the wire on the edge, on the hole, sharp edge? They just tape these two wires together for no good reason? They just one tape two wires? Or are they associated? So we see a small black one going to a terminal. That could be the same black one. Then where's the blue one going? Is it? And maybe it's not blue. Where are we looking here? We're looking there. We're looking right there. And off it goes into the radio from there. If I could pull that tape off, I could see what's happening. Strange to me that they didn't ground it here, but they have their reasons. Sometimes you want to ground shields in only one spot because you don't want it to be part of a current carrying circuit. You don't want any current in that shield. So you just ground it in one spot, and that makes sure it's at the same potential as the chassis, so there's no electrical field between the wire and the chassis, so to speak. Well, I'll just go ahead and replace it. Now, is there any reason why I can't do this blue one? Where'd the blue one go? No, just go ahead and do it and see what happens. Can't really understand what they're doing here, but it sure seems like it could be that the only ground actual tie to the chassis is way back over yonder, way up here, where the shield is opened. So there is no ground. So there's no ground, there's no shield. That would open this cable to being influenced by adjacent signals and accidental sources of feedback and other things. Like maybe even motorboating, maybe. I don't know. Okay, it's still clear what I have to do. I have to replace that wire with my nice yellow wire. Okay, I'm going to do that. Okay, now we're going to find out if I really did get the blue and the black wire right. I'm going to cut away the original wire, and then I'll pull it back. See if it's the same wire. Let's take a look at this with the close-up camera, see what we got going here. The blue wire that turns black. It's really, if you want to be fooled by a radio, here's a good way. This black wire, it turns blue just out of sight. So it comes out the other end blue. It goes in black. Wow. Well, it is that wire though. I was right. So I'll finish making the connection on my new yellow wire. Okay, let's try that again. I didn't heat the terminal up enough first time. Okay, she's on there. Good. Okay, now the other end. This is supposed to come out over here, kind of come around behind the tube. Get rid of some excess wire here. I'm going to try to feed it behind these other wires. Here. Keep it away from that hot tube. Down a little lower. There. That should keep it protected. I have to make the connection here. That's messy. I'm going to take that off with the soldering iron. Put that over that way a little bit. Out. use your soldering iron as a tool. Doesn't want to come out. I got the solution for that. Well, let me take a look at this failed piece of wire. Obviously there's wire in there. I get this cover off, we'll look at the conductor. All the corroded copper has disappeared because none of it was metal, and it just all broke away and gone. It's just powder falling wherever it's fallen. You can see how much metal is actually missing. That's the end of the shield. When it starts, well, it starts under here somewhere. Do with this really. Well, hear it? Yeah, so that's how rubbery this is. The insulation gets like that, any bending of the wire. Okay, we got a little bit of copper there to look at. Looks like copper to me though. I'm curious as to whether it's corroded or not. No, not really. So the inside has remained while the shield got attacked. Probably means the volatile, or if my sulfur theory is right, it could be some other chemical in the rubber here, but sulfur's common. It's just in this outer cover, it's not in the underlying extruded insulation that's right on the conductor. Okay, wow. So this is the first time I've ever changed, I'm pretty sure it's the first time I've changed a shielded wire in a radio. Believe it or not, it's surprising to me. In a way, you know, I'm going to feed this wire. I wish I could keep it from coming over here. I get it down around behind another terminal. It's back here. So this wire I'm using, I have no idea what kind of heat, you know, how capable it is for heat. No reason to think it isn't like any other wire. So, you know, most of this stuff is good for 100 degrees C, and much of it probably way beyond that. That's going to be it there. Okay, so if I cut it here, just a little bit, so I can tug it out briefly. Cut it about here, and then I shove it into place. This is where I cut it too short always. I can always cut it shorter. Cut it like that. Tidbit. I think this is way too long. I'll have to pull it back if that's the case. Pull it back under here. Okay. See if I can get it down under the resistor here. Good. Perfect. Don't move. Nobody move. So I'm going to give this a 50-50 chance that this is the cause of the motorboating. Ah, popped off. 50-50. And I think an awful lot of troubleshooting would be required to determine that this wire is the problem, if that's the way you're going to find it, through troubleshooting, as opposed to what I luckily did, which was direct observation. Lucky, lucky, lucky. Should have seen it the first time around, really, when I was originally inspecting the radio. But you know, I mean, you can only, right? You can't know what you haven't found yet, you know, you can't. It's another version of something missing. You've missed something. It's really hard to find things that are missing. The other thing too is, you know, once you do an action on something like this or anything, once you do the action in your head, you say, well, that's done, on to other things. But maybe something went wrong with the action you didn't realize. You're not likely to come back to that issue for a long time because it's settled in your head. And so this whole troubleshooting business is tricky. And by that I literally mean you get tricked a lot. You know, you're putting together a puzzle. Nobody really is telling you too much about what it looks like. You're finding the pieces. You don't know if you got all the pieces now? I don't know. So whatever pieces you've discovered in the puzzle, you start trying to figure out what, you know, what the picture is. And you might have, you know, you just haven't found out enough yet. But you're compelled to try to figure out the picture with whatever you've got in your hand. So you figured out 3 things and you're working away on that, but there's actually 9 things that you need to take into account, but you don't know it yet, and you can't know it until you stumble on it. This is really a very, very strange business, troubleshooting. Yes, there are procedures to follow to get you down the road, but I don't think any of those procedures would have discovered this wire. They would just discover something's wrong, and you'd be left to figure out what it is. So yes, there's a whole procedural way of doing this work, and I sort of half follow it. You know, I think a lot of people would say there's an art to doing this. I'm not exactly sure whether that's the right word or not. Let's just take a close look at this before we turn on the radio here. So that resistor solder strike, that's not for me just now. Well, it looks a little ugly, but it's soldered. Let me give it a wiggle here, if I can. Oh. Yeah, I'm sure it's soldered. It's amazing how much better these things look from a distance. Hey, that's true of all of us, isn't it? I think so. And the other end went fine. The other end. Wow, that looked great, you know, because I was looking at it from the top side where I threw the solder on it. And it's all covered in solder, but underneath here, that's not so good looking. But again, it's probably just fine. I should really wiggle that. Can I wiggle it? No, it's a little hard to wiggle. Yeah, I'm sure it's soldered in there good enough. And then the other, where's the other end of the wire? Must be around behind there. Can't really see it. Okay, I'm sure it's okay. We'll find out when I turn it on anyway, which I'm about to do. Okay. There's an unexpected repair there. Better put this tube back in. You got wires to cook. Okay, the wire cooker's in. Here's another wire trying to get cooked here. Okay, cooking element in, and power, audio plug. And there's going to be something here. So today is started out. Oh, did I say I got up at 5:30 this morning to watch the sunrise over Lake Couchiching to see the annular eclipse that should have been virtually 100% at the moment the sun came up over the lake. Something like that. It's the best I could figure out from looking at charts and that. If it's not 100%, it's very, very close. And this is an annular thing where the sun is bigger than the moon. So there's never a time where the sun shuts down. It's just occluded and there's a ring. But I think looking at it with your eye, you really couldn't see anything at all, ever. You might perceive the sun being a little weak, which it kind of looked that way this morning when I got up. No matter what I did, I could not see the effect. The sun came up, there were some clouds, I had to wait a while, I had to let the sun come up a little higher. Maybe it was 6:30. By the time the sun was clear in the sky, I could see it, and then I had magnifiers, I had a pinhole box, I had everything ready, and not one thing would image anything interesting at all. So it's disappointing. 5:30 in the morning. Yeah. Uh-oh, a little problem happened here. See my hard drive? So what happened is my hard drive on my computer got full. This is the backup drive that I copy all my files onto. There's gigabytes of stuff on here. So unfortunately, the recording software just stops. I didn't get a message or anything clear. You know, there's a message on the screen, but I didn't notice it. So the bottom line is I went through the process of starting up this radio, and none of it got videoed. So I'm going to do it again. We're going to do it again. I already know what's going to happen. So we're going to switch it off to start. Apply power. I'm going to go for the AM radio. Okay, we're running the radio with 111 volts. Let's take it up a little bit higher. Like that. 118, so this is a typical. So we're on the broadcast band. Notice no motorboating. So that wire was the problem. Okay, see what we can find here. Pointer's right here, a little hard to see. Now, wait a minute here. I'm picking up a station before. Maybe it's the antenna angle. Let me change the angle. How do you like that? I don't like that. No, it won't do it. That's odd. Okay, you'll have to believe me when I said it picked up something on AM before. Now on FM, I've plugged in the real FM antenna here. There we go.
That original song.
Pointers.
July 22nd. Details at Fresh 93 and online. Young Brownies.
That sounds great. Now, did you hear them say 93? If you take a look at the dial, this is 90, 91, 98, 88. So it's 90, 89, 88. They said 93. The pointer's right here above my finger. 90, 91, 92, 93. Should be over here. That's twice on this radio I've picked up a station, it's identified its frequency, and it's off by this much. That's quite a bit. especially if this is 93, you can't go much lower. For instance, the station I regularly listen to is 91.5 CBC here in this area. It's off the dial. So we really want to correct that. And there's probably a few other issues with it. Let's listen to it a little bit. Weak signal. It's fairly weak too. These radios need to be tuned absolutely precisely to get rid of distortion. That's some kind of interference. Let's just go back to that. Is this my is it my soldering iron? It is. How do you like that, eh? I discovered the lamps that I use around here, just like this one here. I'm using lamps similar to this in my office, and I found out they produce interference, but not down in the high frequency band. They produce it starting up around 40 megahertz, something like that. And so, crazy. Not something I expected. Let's keep tuning here. Something else making. Can't see it, the pointer's right here now. For a lot of weak signals here. Oh, there's one. Very good. Now, this would be roughly 108 now, so we're kind of going off the FM dial and going up into where we can pick up aircraft. Is there a chance of that happening? There would be a chance of it. We don't know what frequency this actually is. But I guess it would be like 113, 114. Don't know the airline frequencies offhand. I regularly listen to the airplane frequency that pilots use, small plane pilots use, when they're flying into uncontrolled airports, which there are many, many, many. There's a couple near here, one of them just across the lake, basically. And I can listen to the planes as they call out on this frequency, which I can't remember right now. Basically calling out to anyone who might be interested in what they're doing. They're going to land their plane at so-and-so airport. There could be another plane flying. They don't know about it. They'll hear on the radio, oh, you're going to land there? Well, I'm going to land there too. And these two guys will start talking together. There's no control from the ground whatsoever. They have to decide for themselves what they're going to do. It's not a big deal. It happens all the time. It's routine stuff. I like listening to it. It's kind of interesting. I look up in the sky, I can see the plane and hear the pilot talking. It's kind of neat. Okay. So where am I at with this? I still have it on. So I think that's it for today. What's left now is a tune-up, and I'm a little anxious about doing that in a German radio, but I think we can make some mileage if I'm careful with it. And I've received some more information about this radio from those of you who are kind enough to take the time to find some more. Maybe there's some good alignment information in there. I'll make it a little bit easier to do. So thanks so much for watching the video, and tomorrow we'll try and finish them right off.